On December 12th, the scientific community was forced to accept a shocking conclusion. ThreeI Atlast may be a living entity, and its arrival could mark the end of humanity. Atlast carries a 16-hour heartbeat, absorbs and regulates solar energy, like a mature organism conceals its true structure whenever observed, and moves along a trajectory so precise it defies natural explanation. Its chemical composition from intricate organic compounds to molecular chains resembling protogenetic structures suggests that Atlast may be the remnant of a collapsed planet, a plasma-based life form, or even an interstellar biological vessel created to preserve the memory of a lost world. Its trajectory ejected violently from the Lyra star system along with a thick cryogenic-like ice mantle and layered molecular shielding gives Atlast the appearance of both a wandering messenger and a coffin carrying the final biochemical heritage of an extinct biosphere. And as Earth prepares to enter the debris stream that Atlast has left behind, humanity is confronted with an urgent question. Has it come to seed life, to deliver the final testament of a vanished planet, or to fulfill a purpose beyond anything we can imagine? ThreeI Atlast has now surpassed every boundary of our understanding. But in order to find the final answer, scientists will not stop, and right now, we will continue the journey to uncover the true life hidden within Atlast. Harvard astrophysicist Avi Loeb has ignited one of the most alarming debates in modern astronomy by suggesting that ThreeI Atlast may have already shaped the fate of entire worlds, either by seeding life across the galaxy or by extinguishing it with the same ease. His argument is not built on metaphor but on the unnerving consistency of Atlast's chemistry, its improbable trajectory and its history as a wanderer from a shattered star system. Yet a third hypothesis now surges through the scientific community, with even greater intensity the possibility that ThreeI Atlast is not a passive object at all, but a plasma-based life form. Researchers point to the impossible rhythm pulsing from the comet's core, a 16-hour cycle that behaves more like a heartbeat than a rotational artifact. They highlight its capacity to absorb solar energy without destabilizing, as though ThreeI Atlast were feeding, storing and regulating power with deliberate control. Such behavior has no place in conventional comet physics, yet ThreeI Atlast displays it repeatedly, almost confidently, as if asserting an internal order no natural debris should possess. If Loeb's warnings hold true, then ThreeI Atlast is not merely visiting the solar system 3. Atlast is revealing itself, hinting at agency and tension, and a role in cosmic biology far more profound than anything humanity has ever confronted. Data collected across observatories reveal that ThreeI Atlast carried an internal modulation far too stable to be dismissed as random sublimation. The regularity of this heartbeat-like fluctuation pushed scientists toward an uncomfortable boundary, where known physics lost its footing. An anomaly surfaced when the amplitude sharpened after Atlast crossed a region of solar wind, suggesting not decay, but responsiveness. This shift forced a bridge into speculation, and Atlast began to look less like debris and more like a functioning organism or mechanism. Emotion entered the discourse as astronomers recalled how few chances humanity had to understand interstellar wanderers. ThreeI Atlast seemed to move with purpose, as if carrying an inheritance capable of renewing life or ending it. The transition into deeper inquiry arrived naturally. If ThreeI Atlast possessed structure, rhythm and reaction, then the next step was no longer to ask what Atlast was, but what Atlast intended as December drew near. ThreeI Atlast entered the field of imaging with a contradiction that unsettled every assumption about observational clarity. When amateur astronomers captured crisp, delicate surface details of Ganymede from backyard telescopes, the scientific community expected that professional arrays would reveal ThreeI Atlast with overwhelming sharpness. Instead, every high-resolution attempt produced frames softened to the point of abstraction, as if Atlast dissolved the moment photons tried to record its outline. The disparity forced a quiet pause. Why did clarity fail only when ThreeI Atlast was the subject? Data reviews showed no instrumental errors, no saturation spikes, no tracking faults. The anomaly sharpened when sequential frames displayed micro-patterns of blur identical across different observatories, suggesting not randomness but consistency. ThreeI Atlast seemed to interfere with its own observability, a behaviour deeply incompatible with passive celestial bodies. This bridge from coincidence to suspicion emerged slowly, yet the more researchers compared archival footage, the more Atlast appeared to withdraw from optical scrutiny. Emotion crept in, as analysts confronted the uneasy possibility that ThreeI Atlast was not merely difficult to image but actively concealing structural truth. Atlast behaved like an object aware of being watched dimming key contours, as if guarding internal architecture from unauthorized inspection. The transition point arrived when one team proposed that Atlast's coma might contain a refractive distortion layer, a natural veil or engineered shield. Such a mechanism would mean ThreeI Atlast was not only arriving with purpose, but choosing which parts of itself humanity was allowed to see. 3. Atlast entered the realm of interpretation when a remote viewing sketch drawn weeks before new images were released matched the silhouette of Atlast with unnerving accuracy. Researchers accustomed to strict empiricism hesitated, yet the alignment between the early drawing and the later observational frames could not be ignored. 3. Atlast appeared with tiered contours and a recessed core exactly where the sketch had placed them, creating an anomaly that pressed the scientific community toward questions they preferred not to ask. If Atlast's form had been perceived before being photographed, what kind of signal was ThreeI Atlast projecting into human intuition? Data analysts traced orbital harmonics and noticed that ThreeI Atlast travelled along a trajectory that brushed ancient gravitational corridors associated with theories of a long-lost 10th planet. The resonance did not confirm the existence of such a world, yet the alignment served as a bridge between archaic myth and emerging astrophysical irregularities. ThreeI Atlast behaved as though it carried an imprint of an older architecture of the solar system, a memory encoded in motion rather than light. Emotion surfaced when astronomers admitted that Atlast's path resembled a warning route, a passage historically speculated to precede the reappearance of distant perturbers. The transition sharpened when models showed that ThreeI Atlast maintained this alignment, despite solar wind pressure and perturbations from Jupiter. Such resilience suggested intention or ancient momentum preserved across cosmic ages. With each simulation, ThreeI Atlast seemed less like a drifter, and more like a messenger travelling along forgotten routes, hinting that its arrival might be part of a larger celestial pattern humanity had yet to decipher. ThreeI Atlast entered philosophical territory the moment researchers realised its behavioural profile could support two opposing archetypes, a cosmic gardener or a silent executioner. Atlast displayed traits consistent with biological seeding complex chemistry, stable modulation, protective layering, yet the same traits could be interpreted as precursors to sterilization events witnessed in astrophysical history. ThreeI Atlast carried a duality that forced scientists to revisit the ancient question of whether interstellar visitors nurture life or extinguish it. The anomaly deepened when Atlast's elemental ratios matched signatures found in both prebiotic reservoirs and extinction layer deposits across multiple planetary studies. Data comparison created a bridge that unsettled the entire discourse. When researchers modelled how ThreeI Atlast would behave if it were dispersing organic scaffolds, the simulations aligned neatly with the object's measured emissions. But when the same team tested Atlast under parameters of a planetary cleansing mechanism, the trajectories and distribution patterns matched as well. ThreeI Atlast existed in a spectrum where creation and destruction were mechanically indistinguishable, from a distance a paradox embedded in its every movement. Emotions seeped into the debate as observers contemplated the scale on which Atlast might operate. A single pass of ThreeI Atlast could enrich atmospheres or erase ecosystems depending on the nature of its cargo and the intent, if any, behind its travel. The transition toward deeper inquiry solidified when Loeb remarked that Earth across 4.6 billion years statistically should have encountered at least one interstellar intruder with such power. 3. Atlast now embodied that statistical shadow, compelling humanity to consider whether Atlast approached as a bearer of seeds or the final echo of a long-extinct cosmic purge. 3. Atlast revealed its most unsettling feature when analysts isolated a pulse sharp enough to mimic an internal heartbeat, a rise and fall cycle that returned every 16 hours with unwavering precision. Atlast defied the expected chaos of cometary outgassing, behaving instead like a system governed by internal regulation. ThreeI Atlast displayed amplitude curves that grew more coherent under solar stress, suggesting that Atlast responded to environmental input rather than degrading beneath it. The anomaly pushed researchers toward the threshold where natural explanations thinned and engineered, or biological frameworks began to fill the silence. Data review exposed a bridge into deeper speculation. Historical records held no reliable documentation of ancient interstellar interventions, Yet the stability of ThreeI Atlast's signal resembled rhythmic processes associated with living systems or artificial reactors. When Atlast crossed regions of intense magnetic turbulence without losing pulse coherence, the findings suggested a compartmentalized interior maintaining controlled cycles. ThreeI Atlast appeared to store, redistribute, or convert energy in ways that no dormant rock should, opening the possibility that the pulse did not emanate from the surface, but from layered subsystems inside Atlast itself. Emotion joined the analysis when one team proposed that ThreeI Atlast's heartbeat could represent a diagnostic readout, a window into hidden operations continuing beneath its icy armour. The idea that Atlast might contain chambers, conduits, or a resonant core hinted at processes far beyond geological chance. The transition sharpened as researchers accepted that ThreeI Atlast's pulse, whether biological or mechanical, was not a byproduct of decay, but a signature of activity, an internal rhythm that implied Atlast was not simply passing through the solar system, but functioning within it. ThreeI Atlast carried its 16-hour luminosity cycle with a discipline that resisted every conventional explanation, a rhythm too exact to emerge from random sublimation or rotational scattering. Atlast maintained this period even as solar wind density shifted and thermal gradients fluctuated across its trajectory. ThreeI Atlast behaved as though an internal metronome governed the timing, a mechanism or physiology capable of holding pattern amid cosmic turbulence. The anomaly deepened when instruments detected that the modulation sharpened rather than weakened as Atlast neared regions of heightened solar radiation. Data modelling introduced a bridge into broader speculation. When researchers tested whether the pulse could stem from rotational wobble, the predicted light curves diverged sharply from the observed pattern. ThreeI Atlast delivered a waveform too clean to be accidental, a stacked signal that looked layered, perhaps a combination of surface venting, internal resonance, and energy redistribution. The possibility arose that Atlast used the cycle as a regulatory loop akin to respiration, or thermal buffering, rather than an unintended byproduct of surface activity. ThreeI Atlast seemed to adjust its pulse in response to environmental input, marking it as an adaptive rather than passive traveller. Emotion found its place when astronomers realised the cycle had persisted across weeks, without measurable drift, a level of stability reminiscent of engineered systems or persistent biological rhythms. ThreeI Atlast appeared to communicate through light, its pulse echoing through telescopic logs like a quiet, timed assertion of presence. The transition to the next stage of inquiry formed naturally if Atlast's 16-hour cycle acted as a foundational function. Then uncovering its purpose might reveal whether ThreeI Atlast signalled endurance intention or an encoded message woven into the heartbeat of an interstellar wanderer. 3. Atlast entered the debate on exotic life when chemists confirmed an elemental profile, unlike any cometary nucleus ever catalogued, a composition that favoured high nickel concentration and an extreme CO2 to water ratio. Atlast displayed traits that aligned more closely with theoretical plasma organisms than with inert interstellar debris. ThreeI Atlast showed luminosity gradients and charge distributions that behaved as if Atlast maintained a stabilized plasma envelope, a kind of shimmering sheath capable of shielding and shaping internal processes. The anomaly deepened when simulation suggested that such an envelope could host proto-intelligent behavior, responding dynamically to solar input rather than passively absorbing it. Data from multiple observatories created a bridge into the realm of speculative biophysics. ThreeI Atlast emitted field fluctuations consistent with self-generated magnetic boundaries patterns, previously discussed only in models of plasma-based lifeforms, proposed by David Bohm and other physicists, exploring consciousness in non-material substrates. Atlast reacted to solar wind not with fragmentation, but with cohesive restructuring, as if the plasma surrounding ThreeI Atlast tightened its configuration to preserve internal stability. The coherence of this reaction challenged assumptions about what matter must look like to participate in adaptive behaviour. Emotion threaded through scientific discussions as researchers confronted the possibility that ThreeI Atlast represented a lifeform untethered from water carbon chains or cellular constraints. Atlast might embody a minimalistic organism, a luminous consciousness carried in electromagnetic waves sculpted by fields rather than flesh. The transition toward deeper analysis emerged naturally if ThreeI Atlast possessed a plasma body with proto-intelligent regulation. Then understanding its interactions with the Sun could reveal whether Atlast was learning, surviving, or simply following a script written in the early architecture of the cosmos. ThreeI Atlast revealed a new layer of complexity when solar observatories documented its encounter, with a coronal mass ejection, a violent burst that should have stripped or destabilized any fragile interstellar body. Instead, Atlast brightened. Its pulse strengthened and its coma reorganized with uncanny symmetry. ThreeI Atlast behaved not as an object harmed by solar energy, but as a structure that absorbed and redistributed it, prompting researchers to consider whether Atlast used the sun the way a traveller uses a charging station. The anomaly sharpened when models showed that Atlast's luminosity increase matched energy intake rather than thermal decay. Data analysts found a bridge into deeper speculation by comparing Atlast's response to plasma-based propulsion concepts. ThreeI Atlast displayed acceleration inconsistent with gravitational influence alone and lacked the directional jets typical of sublimation-driven thrust. Atlast appeared to convert solar influx into streamlined motion, a behaviour more reminiscent of controlled energy harvesting than passive heating. The notion gained weight when spectrographic readings indicated reconfiguration within the coma, as if ThreeI Atlast tightened its magnetic envelope to retain absorbed power. Emotion entered the discussion as astronomers realized the implications of an interstellar traveller capable of refueling from stars. ThreeI Atlast seemed to navigate solar terrain with practiced efficiency, responding to the sun's outburst as though following an internal protocol rather than reacting chaotically. The transition into broader inquiry formed naturally. If Atlast could recharge, then its journey through the solar system was not random wandering, but a calculated passage raising the question of how many other stars ThreeI Atlast had visited, and what purpose guided its path across the galaxy. ThreeI Atlast entered molecular analysis with a defiance that startled every laboratory following its trajectory. Atlast produced a spectral line so sharp, so coherent, that it resembled a deliberate stroke of light carved into the data rather than a natural chemical smear. ThreeI Atlast presented a chain signature far more intricate than any molecule expected to survive interstellar radiation, its pattern echoing the scaffolding of primitive ribose phosphate structures associated with early genetic architecture. The anomaly intensified when the line resisted dispersion, under filtering behaving as though the molecular carrier beneath Atlast's coma wanted to be found. Data teams traced the wavelength and identified a bridge into unprecedented territory. ThreeI Atlast seemed to house a molecular chain too organized to be dismissed as random polymerization, a sequence with hierarchy repeating motifs and nested bonds. Atlast challenged the assumption that prebiotic chemistry in space must be simple, instead revealing a molecule with the kind of internal order that suggested function rather than accident. The detection triggered hushed speculation about directed panspermia-engineered precursors or the remnants of extinct biologies travelling through cosmic time aboard ThreeI Atlast. Emotions surfaced as researchers recognised the historical weight of the discovery. ThreeI Atlast appeared to carry not dust, not ice, but information, a chemical stanza from a forgotten world encoded in atomic rhythm. The transition toward deeper inquiry unfolded naturally if Atlast bore a molecular message, resilient enough to reach the solar system intact. Then deciphering that message might reveal whether ThreeI Atlast was transporting the seeds of life, the fragments of death, or the final whisper of a civilization lost to the stars. ThreeI Atlast forced a revision of every protective chemistry model when simulations showed that the complex molecule detected in its spectrum could not survive open exposure to interstellar radiation. Atlast carried a chain so delicate that cosmic rays should have shattered it within years, yet the signature remained intact across millions, perhaps billions of years of travel. 3. Atlast exhibited absorption curves that implied shielding a uniform dampening of high-energy interference that no ordinary cometary crust could provide. The anomaly deepened when thermal models revealed that the molecule within Atlast existed in a stability zone far colder and far more insulated than the surface layers would allow. Data from infrared mapping created a bridge into a new hypothesis. ThreeI Atlast appeared wrapped in an unusually thick ice mantle, a cocoon dense enough to function as a cryogenic vault. Atlast preserved gradients inconsistent with passive formation, as though the mantle were arranged to minimize radiation flux toward the molecule's core. Researchers noted micro-refraction signatures hinting at stratified layers, perhaps deposited intentionally or through a catastrophic process that sealed ThreeI Atlast's cargo in an instant. The structure resembled containment more than coincidence. Emotion threaded through the analytical quiet when a veteran astrophysicist remarked that ThreeI Atlast behaved less like a drifting shard and more like a courier. Atlast moved through space with the poise of something guarding a fragile memory, its layers shaped by forces no longer present, yet still fulfilling their ancient purpose. The transition forward took hold as teams realized that understanding the protective architecture encasing ThreeI Atlast could reveal why Atlast was chosen or formed to carry a molecular relic across the darkness between shattered worlds. ThreeI Atlast pushed the scientific debate into a sharper divide when researchers reconstructed the molecular signal hidden within its spectral line. Atlast revealed a hierarchy of bonds, nested structures and repeating intervals that looked less like a chaotic chemical accident and more like the remnants of a designed architecture. ThreeI Atlast challenged the long-held assumption that interstellar molecules should be primitive, scattered and functionless, instead presenting a chain whose internal order suggested purpose. The anomaly intensified when reverse engineering efforts showed that the molecule's stability profile aligned with patterns found in early terrestrial biochemistry, but with extensions no natural process on Earth could produce. Data groups attempted to restore caution by arguing for improbable, yet possible chemistry. ThreeI Atlast, they insisted, might simply mirror reactions occurring in rare cryogenic niches of collapsing nebulae, but models failed to generate anything resembling the layered structure detected around Atlast, and each iteration widened the gap rather than closing it. The bridge toward intentionality grew stronger when analysts noticed rhythmic bond spacing that echoed regulatory segments found in primitive ribose phosphate frameworks. ThreeI Atlast seemed to carry the kind of molecular sophistication that forced scientists to rethink where randomness ended and direction began. Emotion entered the conversation as teams confronted a possibility both exhilarating and unsettling. ThreeI Atlast might be transporting the biochemical echoes of a world that once organized matter into meaning. Atlast stood at the crossroads of accident and intention, asking whether life elsewhere arises from blind chemistry or from processes that leave signatures of deliberate assembly. The transition forward sharpened as researchers prepared to examine whether ThreeI Atlast's molecular fragment belonged to a larger genetic system, one that might have collapsed along with the world that formed it. ThreeI Atlast revealed its most haunting implication when thermodynamic simulations demonstrated that the detected molecule could not exist as an isolated fragment. Atlast displayed a stability curve that only made sense if the chain were once part of a far larger biochemical network, a system with redundancy, hierarchy and interlocking functions. ThreeI Atlast carried fluctuations in its spectral tail that hinted at microvariants, slight deviations in wavelength, that resembled broken branches of a once-connected genetic scaffold. The anomaly deepened when analysts realized these variations fit together like shards of a shattered code, suggesting that Atlast preserved the remnants of something far more complex than a lone molecular survivor. Data modeling provided the bridge into a broader reconstruction. ThreeI Atlast appeared to contain frozen residues arranged in stratified patterns, as if multiple layers of a biological archive had been compacted and sealed in the moment of a planetary catastrophe. Atlast exhibited thermal signatures consistent with rapid cryogenic encapsulation, the kind generated when a biosphere is flash-frozen by gravitational collapse or stellar upheaval. The idea emerged that ThreeI Atlast did not form a molecule, it inherited one carrying the amputated limb of a greater system, whose full architecture once thrived under a distant sun. ThreeI Atlast thus resembled not a container but a survivor, carrying the smallest intact memory of an entire living world. Emotion threaded through the analysis as researchers realized they were not merely studying chemistry, but eavesdropping on the afterlife of a planet. ThreeI Atlast seemed to whisper of ecosystems extinguished in an instant, leaving behind only the fragments that could ride an icy projectile into interstellar night. The transition forward took shape as teams prepared to trace the origin of this frozen obituary, seeking the star system where Atlast's larger molecular family had once lived, evolved, and ultimately vanished. ThreeI Atlast exposed a deeper cosmic tragedy when orbital models were wound backward through millions of iterations. Atlast traced a path not of gentle wandering but of violent expulsion, its velocity and angle implying that ThreeI Atlast had been hurled from its birthplace with catastrophic force. Analysts linked this trajectory to a once stable binary star system in Lyra, a pair whose gravitational harmony may have collapsed into chaos. ThreeI Atlast carried acceleration signatures consistent with debris flung outward during the final convulsions of a dying stellar pair, a moment when planets, moons, and atmospheres were torn apart and scattered into interstellar darkness. Data refinement formed a bridge toward an unsettling hypothesis. 3I Atlast appeared to have been part of a planetary crust or subsurface layer ripped loose in the instant a habitable world succumbed to tidal disruption. Atlast's cryogenic mantle matched models of debris cooled so rapidly that complex molecules were flash frozen before radiation could erase them. 3. Atlast thus resembled a shard of a planetary obituary launched into the galaxy not by intention but by the blind violence of celestial collapse. Emotion surfaced as researchers confronted the scale of the ruin encoded in 3I Atlast's journey. Atlast travelled as a witness from a world that no longer exists, carrying fragments of its final moments across the gulf between stars. 3I Atlast entered the biological discussion when analysts realised that the molecular fragment it carried behaved less like a random survivor and more like a relic preserved by catastrophe. Atlast displayed spectral irregularities that aligned with models of biospheres frozen in the instant of planetary death, where complex molecules are sealed before heat pressure or radiation can dismantle them. 3I Atlast held microsignatures, minute shifts in wavelength, subtle overlaps in harmonic spacing that resembled the biochemical noise left behind when an ecosystem collapses. The anomaly sharpened when researchers observed that these variations followed patterns consistent with population-level genetic diversity, as if Atlast preserved the faint echoes of an entire living world. Data synthesis created a bridge into a more profound reconstruction. 3I Atlast seemed to carry not one molecular lineage but traces of several compressed into stratified bands that behaved like geological layers written in chemistry rather than stone. Atlast mirrored the kind of distribution found when multiple biological systems are extinguished simultaneously, each leaving its chemical fingerprint within a shared vault. 3. Atlast thus appeared to serve as a time capsule forged by destruction, a vessel that enclosed biological memory in the moment a planet fell silent. Emotion grew in the scientific community as researchers contemplated the meaning of such preservation. 3I Atlast did not merely transport molecules, Atlast transported context, the faint resonance of interactions, metabolisms, and histories that once unfolded under a different sky. The transition forward solidified when teams accepted that decoding 3I Atlast's molecular layers meant listening to the last breath of a vanished biosphere, an afterimage carried across cosmic distances in the chemistry that Atlast still guards. 3I Atlast challenged humanity's deepest assumptions about life the moment researchers recognized that its molecular cargo could not be dismissed as an isolated accident. Atlast presented a chain so intricate and so resilient that its survival across interstellar time implied not rarity but repetition. 3I Atlast forced scientists to reconsider the long-standing belief that life requires narrow, improbable conditions, liquid water, moderate temperatures, stable energy gradients, because the fragment preserved within Atlast appeared to have endured environments far beyond those boundaries. The anomaly sharpened when comparative studies showed that Atlast's biochemical signatures could theoretically arise in countless star-forming regions, meaning that similar carriers may have crossed the galaxy long before 3I Atlast arrived in the solar system. Data from astrobiology groups created a bridge into a radical reframing of cosmic habitability. 3I Atlast suggested that life's foundations might be distributed like dust, drifting through molecular clouds attaching to newborn worlds and surviving stellar upheavals. Atlast became evidence that biology could be a galactic process rather than a planetary miracle emerging wherever chemistry and time intersect under protective conditions. Emotion spread quietly within the scientific community as teams realized that 3I Atlast had not merely expanded the map of life, it had erased old borders hinting that the universe may be saturated with seeds waiting for a place to grow. 3I Atlast entered theoretical biology when researchers proposed that its molecular fragment might not represent the ruins of life, but a different category of living system altogether. Atlast carried a signature that did not fit cellular frameworks, metabolic pathways, or water-dependent chemistry. 3I Atlast instead displayed properties consistent with cryogenic stability patterns, suggesting that the molecule functioned only at temperatures near absolute zero, where motion slows and information persists through stillness. The anomaly grew sharper when models showed that Atlast's spectral rhythm could represent regulatory behavior, a minimal pulse that maintained structural coherence rather than driving metabolism. Data comparisons built a bridge toward the cryogenic organism hypothesis. ThreeI Atlast resembled a form of life that survived by freezing rather than by burning energy, a being whose existence unfolded across epochs rather than moments. Atlast's protective ice mantle and magnetic envelope formed conditions in which such entities might remain intact, travelling star to star as dormant passengers, awaiting environments where replication could begin. ThreeI Atlast thus blurred the line between molecule and organism, suggesting that life might emerge not from warmth, but from cold, not through motion, but through preserved pattern. Emotion entered the discourse as scientists confronted what this meant for cosmic biology. ThreeI Atlast implied that the universe might harbour species whose timescales dwarf galaxies' beings encoded in frozen chemistry, drifting endlessly through interstellar dark. The transition forward solidified when researchers asked whether Atlast carried a cryogenic lifeform, awaiting reawakening, or whether ThreeI Atlast itself was that life. ThreeI Atlast entered chemical analysis with a profile so extreme that it overturned every baseline model of cometary composition. Atlast carried methanol and hydrogen cyanide in concentrations far beyond anything measured in solar system objects, creating a biochemical landscape more reminiscent of prebiotic laboratories than natural ice. ThreeI Atlast displayed a CO2 to water ratio of 8:1, a deviation so large it registered as a 4.5 sigma outlier, statistically incompatible with formation within the Sun's protoplanetary disk. The anomaly sharpened when isotopic comparison showed that Atlast's materials bore signatures consistent with star systems billions of years older than Earth. Data from spectroscopy created the bridge into deeper cosmochemical inquiry. ThreeI Atlast matched patterns associated with interstellar carbonaceous bodies formed in regions rich in supernova ejecta, where complex organics condense under intense radiation and cold. Atlast did not resemble a comet shaped by quiet accretion. Instead, its chemistry suggested violent origins forged in environments where life's building blocks accumulate in dense reactive layers. ThreeI Atlast thus carried an organic reservoir so rich that a single pass near a young world could alter its atmospheric balance or contribute raw ingredients for emerging biospheres. Emotion formed at the edges of scientific dialogue as researchers realized the magnitude of material ThreeI Atlast transported. Atlast seemed less like a passive visitor and more like a drifting archive of primordial chemistry, a vessel holding ancient compounds older than the solar system itself. The transition toward the next investigation emerged naturally. If ThreeI Atlast possessed such dense concentrations of life-forming molecules, then the mechanisms releasing those materials eruption, heating or controlled discharge would reveal whether Atlast acted accidentally or with intentional efficiency as it moved through stellar space. ThreeI Atlast revealed one of its most dramatic behaviours when observers recorded a sudden surge in brightness on September 7, 2025. Atlast brightened by nearly 2 magnitudes in a single event, a jump equivalent to a 6-fold increase in visible output. ThreeI Atlast produced this eruption while still more than 2 astronomical units from the Sun far beyond the zone, where typical comets experience significant heating. The anomaly pressed researchers to reconsider the internal structure of Atlast, because no single vent or fracture could account for a release of this scale and symmetry. Data reconstruction formed a bridge into a striking hypothesis. ThreeI Atlast appeared to undergo global cryovolcanism, a phenomenon in which volatile layers accumulated over millions of years erupt simultaneously. Atlast showed rotational uniformity roughly 16 hours per cycle, which allowed solar heating to distribute evenly across its surface. As a result, the entire crust of ThreeI Atlast may have reached a critical threshold at the same moment, triggering a planet-wide outgassing that lifted ancient material into space. The symmetry of the event suggested stratified layering rather than chaotic isolated pockets. Emotion rippled through the astronomical community as the implications came into focus. ThreeI Atlast had not merely shed dust. Atlast had released an archive of chemically rich material across the length of its trajectory, scattering the remnants of interstellar history like the shrapnel of a shattered world. The transition toward further investigation solidified immediately. If ThreeI Atlast could erupt globally, then understanding the forces governing these releases would reveal how Atlast might reshape the environments of worlds that drift through its expanding trail. ThreeI Atlast confronted classical physics when astronomers documented a jet erupting not away from the Sun but directly toward it. Atlast defied the fundamental expectation that solar radiation pressure should sweep dust and gas outward, creating tails that stretch away from stellar heat. 3. Atlast instead generated a concentrated coherent plume, pointed sunward, a configuration that no standard sublimation model could reproduce. The anomaly deepened when the jet intensified as Atlast moved through perihelion, even though other portions of the coma faded under rising thermal stress. Data modelling offered a bridge into unfamiliar territory. 3. Atlast produced flow patterns resembling controlled venting rather than spontaneous outgassing, with velocity profiles that narrowed into a focused channel. Atlast demonstrated stability within the plume, as though magnetic or thermal structures were guiding the material rather than allowing chaotic dispersal. Spectral measurements also showed compositional differences between this sunward jet and the rest of the emissions, hinting that 3I Atlast might be selectively transporting or redistributing internal material. Such directionality raised the possibility of anisotropic heating or internal compartments capable of regulating pressure. Emotion entered the analysis when physicists realized that 3I Atlast behaved as though indifferent to the mechanical rules governing ordinary comets. Atlast seemed to negotiate the sun's force rather than obey it, adjusting its emissions with a precision that suggested underlying order. The transition into the next phase of inquiry formed naturally if 3I Atlast could generate a jet that contradicted outward radiation dynamics. Then uncovering the mechanism behind this reversal might reveal whether Atlast harnessed solar interaction, or whether 3I Atlast possessed an internal system designed to operate in defiance of stellar winds. 3I Atlast entered orbital analysis with a precision that unsettled even the most conservative dynamicists. Atlast followed a path whose alignment with Earth's orbital plane carried a statistical likelihood of less than 1 in 500, a coincidence so narrow that it pushed the discussion beyond simple gravitational happenstance. 3. Atlast maintained this course despite perturbations from inner planets and fluctuations in solar wind, behaving as though its trajectory were insulated from the random nudges that typically reshape interstellar visitors. The anomaly sharpened when simulations showed that Atlast's inbound angle mirrored vectors associated with targeted transfer routes rather than with stochastic drift. Data refinement created a bridge into speculation about controlled navigation. 3I Atlast demonstrated acceleration curves inconsistent with purely gravitational motion, lacking the chaotic momentum shifts expected from sublimation-driven jets. Atlast instead displayed subtle but continuous corrections, as if responding to forces acting internally rather than externally. These micro-adjustments hinted at either engineered resilience or ancient momentum imparted by a mechanism no longer active, but still dictating the path of 3I Atlast across stellar boundaries. Emotion surfaced as researchers reckoned with the implications of such stability. 3I Atlast travelled like an object following a plan, whether written by intelligence, by catastrophe, or by physics not yet understood. The transition forward crystallized into a single question. If Atlast moved with purpose, then what destination awaited 3I Atlast within the solar system's carefully threaded corridors? 3I Atlast carried a chemical inventory so primitive and so concentrated that researchers began treating Atlast not as a wanderer, but as a courier transporting the raw ingredients of ancient biochemistry. Spectral analysis revealed signatures reminiscent of CR-type carbonaceous material meteorites known for preserving unaltered organics from the dawn of stellar formation. 3I Atlast, however, exceeded those baselines by orders of magnitude, holding methanol complex organics and prebiotic fragments at densities rarely observed in any solar system body. Atlast appeared to have spent millions of years drifting through molecular clouds, supernova debris, and cold interstellar regions where such compounds accumulate layer by layer. This evidence created a bridge toward a more dramatic hypothesis. 3I Atlast might represent a delivery vessel for primordial chemistry. Atlast's layered crust, enriched with volatile carbon compounds, behaved like a sealed archive protecting molecular relics. Researchers noted that the preservation quality suggested not random contamination, but continuous exposure to environments rich in life-building material. 3I Atlast seemed to function as a collector, sweeping through the galaxy's chemical ruins. Emotion entered as scientists realized the scale of what Atlast carried. 3I Atlast was not just rich, it was saturated, a portable reservoir of ancient potential. The transition ahead pointed to a deeper question. If Atlast preserved chemistry older than Earth itself did, 3I Atlast also preserved the story of a worlds long gone. 3I Atlast revealed another anomaly, when thermal reaction models showed that Atlast could generate magnetite across its surface during periods of intense solar heating. As water ice fractured and oxygen bound to iron, a lattice of Fe3O4 formed one of the strongest naturally occurring magnetic minerals. 3I Atlast accumulated these magnetic grains in quantities far higher than expected for an interstellar fragment, suggesting a process that repeatedly reheated and restructured its outer layers. Atlast through these cycles appeared to build a magnetic sheath dense enough to deflect charged particles and soften the cosmic ray bombardment that would normally shred organic molecules. This behaviour formed a bridge into the interstellar panspermia hypothesis. 3I Atlast did not simply endure radiation. Atlast countered it, shielding its organic cargo with a self-generated magnetic buffer. Such protective envelopes are rare in natural comets, yet Atlast displayed a coherent field pattern, resembling a defensive bubble rather than random magnetization. Researchers argued that 3I Atlast's resilience allowed prebiotic chemistry to survive interstellar transit far longer than laboratory models predicted. Emotion entered the debate as scientists recognized the implications. 3I Atlast behaved like an arc, an object engineered by physics or by intention to escort molecular potential across light years. The transition forward sharpened into a single inquiry. If Atlast protected these compounds so effectively, was 3I Atlast acting as a passive relic or as a deliberate participant in the galaxy's long-distance biological exchange? Earth's projected passage through the debris stream of 3I Atlast in 2026 introduced a phase of quiet tension into the scientific narrative. 3I Atlast shed layers of organic-rich dust, volatile fragments, and magnetized particles during its solar approach, creating a drifting corridor of chemistry that continued to expand long after Atlast moved outward. Simulations showed that Earth's orbit would intersect this corridor in March and April 2026, placing the planet inside a diffuse cloud of prebiotic material sourced from 3I Atlast's eruptions. Atlast, having released this material under heightened solar stress, left behind a trail dense enough to alter atmospheric sampling profiles once Earth entered the region. This realization created a bridge toward heightened surveillance efforts. Global observatories prepared to monitor upper atmosphere spectra for unfamiliar carbon chains, isotopic anomalies, or magnetite-bound organics that could descend through atmospheric layers. 3I Atlast through this debris field effectively extended its influence across months rather than moments, turning space weather forecasts into biochemical watch lists. Researchers approached the event cautiously emphasizing that the encounter posed no physical impact threat, yet acknowledging that atmospheric chemistry could register subtle but unprecedented signals from Atlast's wake. Emotion underscored the scientific preparation. 3I Atlast seemed poised to brush Earth with material older than the solar system itself, a reminder that cosmic encounters need not be violent to be profound. The transition ahead led to a lingering question. Once Earth passed through the trail of 3I Atlast, what fingerprints of ancient interstellar chemistry, if any, would remain woven into our sky? 3I Atlast approached the final arc of its journey through the solar system with a kind of forensic weight, as though Atlast were less a visitor and more a witness carrying testimony from eras and star systems long erased. 3. Atlast, after threading past Earth and sweeping toward Jupiter, offered one last narrow window for direct sampling, before accelerating into interstellar darkness at more than 150,000 miles per hour. Atlas' trajectory placed the object within potential reach of instruments aboard Juno, and mission planners quietly examined whether a slight trajectory adjustment could allow the probe to intercept the outer boundary of Atlast's dust stream. Such an encounter would be unprecedented, a probe built for planetary science, brushing against material launched from another star's collapse. 3I Atlast, in this context, became not just an object of curiosity, but an evidentiary archive whose chemistry, magnetism, and structure formed a kind of cosmic autopsy report. The data gathered so far already pushed researchers into a new investigative framework. 3I Atlast contained molecules that behaved like fragments of a genetic ledger. Atlast exhibited jets that contradicted known radiation dynamics. Atlast retained magnetite lattices hinting at long-term shielding. Atlast carried statistical signatures of a guided or at least unusually stable interstellar trajectory. These features did not coalesce into a single narrative, yet each anomaly pressed the scientific community toward the same uncomfortable threshold. 3I Atlast was not a simple comet, and perhaps not even a single-purpose object. It moved like the debris of catastrophe, behaved like a device built for endurance, and carried chemistry that resembled memory more than randomness. This convergence created a bridge toward a broader cosmic reconstruction effort. Astrophysicists began treating ThreeI Atlast as a forensic sample from a disrupted star system material thrown across the galaxy that still encoded the conditions of its birthplace. By mapping isotopic ratios, magnetite orientation, volatile layering, and the directional stability of the debris stream, researchers attempted to reverse engineer the collapse that birthed ThreeI Atlast. Models suggested a binary star destabilization, a chaotic orbital unraveling, and a violent expulsion of planetary crust and atmosphere. ThreeI Atlast in this reading became the drifting remnant of a world's obituary preserved not by intention, but by cosmic accident. Emotion rose quietly behind the analysis. 3. Atlast reminded scientists that the universe keeps records in matter in motion in the scars between stars. ThreeI Atlast carried those records across centuries of darkness, only to intersect briefly with a species capable of reading them. The transition forward settled into a final inquiry as ThreeI Atlast leaves the solar system forever. What part of its long, silent testimony will humanity understand, and what part will remain sealed in the cold, drifting archive that ThreeI Atlast continues to be?